In this segment, we're going to discuss the importance of structured data. Now, we all know this off the top of our heads. We just say, yeah, of course, every time we're doing data analysis, we need structured data. But let's take a look at the real implications of what we're talking about when we're trying to pull structured data from many sources today. Now, most other data sources that we have out on the market today are going to pull their data from EMR systems, electronic medical record systems that the physician or healthcare providers are using, which we all know that. That's a very standard statement. Most data sources are pulling data from an EMR. But let's delve into that just a little bit. In most EMR systems out there, the doctors literally just type a chart note. Or some have the alternative of allowing the physician or healthcare provider to actually build templates, and then they, quote, customize or build their own template. Consequently, the data your source is getting, when we consider that, is certainly not structured. Let's take a second and think about that. So every time a doctor or healthcare provider is typing their note or, quote, customizing and building their own separate template, each physician, each practitioner may be describing these conditions differently. So just as we saw in our early examples, the difference between the hallux abductor valgus cases and the ulcer cases, each healthcare provider could be describing each one of these conditions differently. That introduces hundreds, literally hundreds, of individual new variables, and these variables we really have no way to account for. So in essence, this data is completely unstructured and has massive numbers of variables that we can't account for. We don't even begin to understand the variances when our data is pulled from an EMR system where the doctor is allowed to type the chart note or, quote, build customized templates. Almost all of the data sources today will pull their data from not only one EMR system, but they'll pull their data from multiple EMR systems. So we just talked about the challenges and the issues we run into with pulling data from EMR systems that allow the doctor to type or build a customized template, the variances that we have in our data that we can't possibly account for. Now, if we add pulling from multiple systems, we're literally adding that condition exponentially. So now we've got the same condition not only times one EMR system, but times every other EMR system that your current data source tries to pull the data from. So this data that we're getting from most other data sources out there today is completely unstructured. The variables are just too numerous to even begin to count. So how can we actually ever gain any real depth or really any solid statistical evaluation or insight from that data? This is truly a challenge with other data sources. The Starwriter system completely resolves this issue. So we made a big statement on how important it is to understand if we have variances in our data that we're not accounting for and the lack of structure to our data. But let's use a little more of a visual example so we can really drive that home, the advantage and the difference to structured data with variables that we can account for versus unstructured data and unaccounted for variables. So let's get just a little bit more of a visual example so that we can drive that point home. So let's use an example of one of our mega or superstores. We're all familiar with these out there. Everybody, I'm sure, has one in their particular town or city. These are going to be the stores that have every single thing imaginable in that one store. We'll have maybe groceries on one side, healthcare and beauty products on another end. We'll have clothing on another section, and maybe automotive supplies in another part of the store. So we've all been to these types of mega or superstores. So let's take this as our base example. And here's a couple pictures of how these might typically look. So we can see in these types of stores, we'll have literally all of the inventory beautifully set up on the shelves. You can see again, maybe these are some beauty products or whatever we might have here. Another example here of clothing. That's a great example. And we can see everything's nicely set up either in shelves or on racks. And it makes it very, very simple to go in. For example, let's use the clothing on the right. If you wanted to go in and buy a pair of Levi's 36-inch waist and 36-inch length, you could very easily go in, grab that particular item right off the bin because you'll be able to identify quickly and simply where it is, and you'll be able to walk right out the store. We're all familiar with this. Now, let's take for the sake of our example here, let's say we take all of that inventory in this superstore and we go ahead and we just literally pull it all out of the store. So our store is completely empty. And now we take all the racks and all the shelves completely out of the store. So this is literally just an empty warehouse. There's literally nothing in there. Now we have all of our product and all of our inventory outside, and at the same time, we remove every single label and every single tag. Every single tag off the food, every tag off the clothing, every single tag, every label, every scan code, barcode, whatever it might be, we remove all of those. And then we take and we put all of the inventory back in just piles on the floor. So it might look something like this. We'd have maybe piles of clothes, might have piles of food, piles of back-to-school supplies, whatever it might be. But we would literally have unlabeled piles right back in the store. So what would we have? At that point, we would have our store with all of our inventory. So there would be tremendous amounts of inventory in the store, but yet finding anything and sorting it so that we could pull things out in a reasonable fashion would be unbelievably challenging, if not almost impossible. Using an example of clothing, it would be nearly impossible if all the jeans had no labels, and if they had, so we couldn't tell the size or we couldn't tell the brand, and we just dumped those in on the floor. Now it would be virtually impossible to tell the Lees from the Levi's from the Wranglers, and it would be almost impossible to be able to tell the 32-inch waist, the 34-inch waist, the 36-inch waist. All we would know is that we were grabbing a pair of blue jeans, but we would not know the size of those blue jeans or the brand of those blue jeans. And this is a very classic example for what's going on with our data today. We have everything from these big data warehouses, data repositories, pulling data out of EMR systems. There's massive, massive amounts of data out there. But it's like the diagrams at the bottom. It's just piles of stuff, and we really don't know what we're getting. We really don't know what we're getting. So the variables are unimaginable in the data that we're probably getting today, and it certainly isn't structured data. This really differentiates almost all other data sources. You're getting data from the bottom two diagrams, right? A big pile, and maybe you're getting the Levi or 34-inch waist and a 34-inch length that you're looking for, but you might not be. You might be getting a Lee brand pair of blue jeans that are maybe 38-inch waist and 32-inch length. We don't know because these things aren't labeled and they aren't structured. This is giving you a demonstration of the importance of the structure to the database and the labeling of data as it goes in correctly, as opposed to trying to sort things from a big, huge pile after the fact. All competitors are trying to sort your data from a huge pile after the fact. The Starwriter system is perfectly structured data with variances accounted for, as we see in the two diagrams at the top. And a key question here that we pointed out earlier, does your current data source make you wait some period of time before they can get the data for you? Well, why is that? Because they're pulling data from the two bottom diagrams. In other words, they're trying to pull out of some big massive pile. It takes them forever to try to do that for an extended period of time. You can imagine what a project it would do to try to root through, find the correct food, the correct pair of clothing, whatever it might be. The exact same process has to be taken when we're looking at data. So your current data source, if they're taking an extended period of time, they're doing what's at the bottom, As opposed to the Starwriter system, we literally stream data to you real time. And when you have a perfectly structured database and variables are accounted for, we can stream the data to you in real time, because it's no harder than if you wanted to walk in the store, walk to the Levi jeans, grab the 32-inch waist, 34-inch length right off the rack, because it's perfectly structured, it's perfectly labeled. You could grab that simply and be in and out of the store. There's a similar analogy to the way Starwriter gets you the data. Any data that we pull out of a well-structured database is a simple, straightforward process. That's precisely what Starwriter patented process can do. We can stream perfectly structured data to you. You know precisely what you're getting, and we stream it to you in real time. This is the advantage of the Starwriter patented system.